Sure can. How y'all doing?
Very good. Can you turn up your computer audio, Brent?
Is it my computer audio or is it that audio?
It's going to be both.
Hey, can you guys hear me?
Hey, Anthony. How are you, buddy?
Hey, Steve. I'm doing well. How's everyone doing?
Very good, sir. Assuming they're going to jump in on the downstairs.
Yeah, I think they already are. See, we got two different groups and two different conference rooms, and then a bunch of guys remote.
Gotcha. Okay. Cool. Just whenever y'all are ready, let me know. I got a PowerPoint I'll share with you, and we can either interrupt and ask questions as we go along, or wait till I'm done. It doesn't matter to me. However y'all want to roll with it, I'm good.
Can we see the guys downstairs on?
Unless they're one, I don't know who's running
only
the stuff
two
down
names
there.
down
There's
at
two
the
names
bottom.
down there. I don't know who they are.
More than maybe.
He
was in the room downstairs.
okay. So they're probably on.
Okay.
Can we get an affirmative from the MSS guys downstairs if you guys are on and ready to go? I have to run down there. Swear to goodness. Sorry for the little bit of a disconnected meeting here.
You know how technology is. It's great when it works, and when it doesn't, well, you're
Well,
stuck.
I'm not entirely certain it's the technology's fault this time.
What I used to call a PBKF error. Problem between the keyboard and your fingers.
Do you have logs to your house, Rudy?
Are you guys good? Like all around?
I got that room
I talked to them later about maybe. What's that? You can hear?
All right, now I can hear you guys.
Steve, can you hear us?
I can hear you.
Yep, I can hear everybody.
Ready to roll then.
All right, we'll let you get. I'm gonna put us on mute so you don't hear.
Okay, sounds good. And I'm going to share my screen. Can y'all see my screen?
Yeah.
Okay. Cool. So Paul asked us to come together today and talk to MSS about pressure independent valve technologies. What we're going to do is we're going to take a quick overview on how pressure independent valves work. I'm going to talk a little bit about the OPI CCD. Then our newer or current offerings, which include the PIQCV, the EPIV, the Belimo energy valve, and then I'll also discuss a couple of installations in your territory so you can see that this is not cutting edge or not bleeding edge technology, but it is newer technology.
Hey, Robert, could you guys downstairs put yourselves on mute real quick? A little bit. Yeah. Thanks.
All right. So pressure independent valve technology is pretty common in the HVAC industry these days. A PI valve is simply going to give you a specific GPM for every degree of opening of that valve assembly, regardless of variations in the system. So as the pumps ramp up and down, the PI valves take care of the proper flow, sort of like on the edge of the system, as you will. So we're taking a signal just like a regular control valve does, but it knows either based on a mechanical regulation or electronic reading that there's supposed to be a specific GPM going through that coil and therefore through that valve assembly at any given time. A PI valve basically functions like a control valve and a balancing valve in one valve. So many, many years ago, we did a survey at the Iowa Energy Center, and we took a 1/2-inch globe valve with a CV of 1.6, put it on a coil that was designed for the 3.58 GPMs. We selected the valve at a 5-pound drop. So almost perfect valve authority as far as the valve sizing went. Then what we did was we simply locked the valve open at 40%, which should be on a 1.6 CV globe valve, taking equal percentage characteristics into consideration. It should be a CV of about 0.58. So somewhere around a little bit over 1 gallon per minute should be flowing through this valve when the valve is 40% open or commanded 40% open. So what we see, we open our valve at 5 pounds a drop. We got a little over 1 gallons per minute. But as that pressure drop across the valve increases because of fluctuations in the system, we wind up with a whole lot more water flow than we should have because of the increased pressure drop. From those of us in the control business, we know that as that temperature goes through the water goes through the coil at a specific temperature delta or delta T, we don't necessarily see air side changes right away. And so it takes a while for the system to correct. With PI valves, or with pressure dependent valves, even a little bit of variation. So even from 5 to 10 PSID, we get a certain measured amount of overflow. And that, if it happens at multiple coils or multiple locations in the system, winds up being a lot of excess flow through the system that you don't need. A pressure independent valve, again, just simply maintains a specific GPM based on the degree of opening of the valve at any given time. So we're going to give you the right flow using a pressure independent valve regardless of system variations. So we can see here, although we have a little bit of overflow, it's minimized as that differential pressure across the valve increases. So again, to summarize, basically we are controlling and maintaining balancing and flow all at one given time with one valve assembly. Bulimo got into the pressure independent game back in the early 2000s. We introduced something called the pressure independent characterized control valve, and this was a successful product. It worked really well for Bulimo. Our customers loved it. It ranged from a 1/2 inch to 2 inches back in those days, and from a 1/2 gallon per minute up to 100 gallons per minute. The dilemma behind this product was that at about 1 inch and around 40 gallons per minute, this valve became relatively large in size. And therefore it became expensive because the additional brass casting and all the hardware that went into making the valves made them pretty cost intensive. So this valve is obsolete. We no longer make the PICCV. In fact, I don't believe we even have any leftover old stock. What we do offer nowadays is 3 different types of Belimo pressure independent valve technology. We have a smaller valve that's designed for unitary applications like reheat coils, on VAV boxes, small fan coils, things like that. We have the electronic pressure independent valve, which was introduced back in 2007. So it's got quite a long life on the market and has been very successful. And then we have the Bulimo energy valve, which you may or may not have heard about, but this has been around since 2012. And essentially, it's a pressure independent valve built on the framework of the electronic pressure independent valve that does some delta T management, data logging. It's a relatively sophisticated valve assembly, but it's also really easy to work with. It's pretty much cut and dry. So I'm going to start here with the zone tight pressure independent quick connect valve. That's a lot of words, I know, but we call it the PIQCV. And this is a 1/2 inch and 3/4 inch valve that can be dialed down to control at as low as 0.1 gallons per minute and as much as 9.0 gallons per minute when it comes to a 3/4 inch valve assembly. There are only 4 different models. And as you can see, there's a clip on the front of the actuator. And as this clip is moved or adjusted, you can vary the ranges, say on the Dash B model from 0.1 to a maximum flow of 0.9. The bigger half-inch can control at 0.6 gallons per minute all the way up to 4.3 gallons per minute. The 3/4 inch control all the way down at a maximum flow of 1.6 or a maximum flow of 9.0 gallons per minute. It just depends on how far you let this actuator stroke open, and that is regulated by this clip. We can factory set that clip for you, or it can be done in the field. It's a very easy process. As you can see, there's a table, and you just simply find these numbers on the actuator's body, and you put the clip in the position for the required GPM. And we also provide you the running time, so you know how long it takes to get to full flow. The PIQCV, it's really a zone-style pressure-independent valve, so you can get them with auxiliary switches if you need to interlock a compressor motor with the valve, so the compressor doesn't start on a water source heat pump before the valve's fully open. And it also is available with feedback from the actuator. We found that a lot of the healthcare customers wanted feedback on their zone valves, on their little reheat valves. So it's a pretty fully encompassing actuator and valve assembly line. This is mechanically regulated. So what we have here is we have upstream pressure, we have a measuring port, we have our controlled pressure, and we have a downstream pressure. And as the downstream pressure rises, the regulator closes to maintain a constant 5 psid across this little control orifice here. If my pressure differential stays the same, right? We don't see any fluctuations because this regulator kind of clamps down when the differential pressure gets too high. If I have a fixed DP across the control orifice, I can predict the exact GPM for every degree of opening of that valve assembly. If you fall below 5 pounds of drop, this valve works just like a normal control valve. So it's not problematic if you don't have all the drop necessary, but once you start to get above 5 pounds, this regulator comes into place and makes sure we have a fixed drop across that control ball. One thing I'd like to point out is this is the only pressure independent valve we make that has onboard PT ports. So when we start looking at the EPIV, the electronic pressure independent valve, there are no PT ports on the valve body itself. In this particular situation with the PIQCV, the smaller valve, we of course recommend at least one PT port on the inlet side of the coil, and then the PT ports on the valve can be used to verify flow through the coil and DP across the valve assembly. So again, this is the only valve we're going to provide with onboard PT ports. So that's our little zone valve unitary offering. Again, fan coils, VAV box, straight up reheat coils that you might find in a hospital. From there, we move on to the electronic pressure independent valve. This is a valve that's been on the market since 2007. Back when I was in distribution, I worked for a distributor that's based in Atlanta, but had an office down here in Orlando, which I am here in rainy, cloudy, Central Florida right now. And in 2007, when Belimo introduced the electronic pressure independent valve, I sold a project to what was then Florida Hospital and now Advent Health. And I was down at that facility a couple years, and those 13 EPIVs that I sold in 2007 are just humming away, working great. So it's a pretty robust, pretty well put together product. What we use is we use an ultrasonic flow meter. So it's a transit time flow meter in the valve assembly. And as we get valve flow through the valve, we measure that and compare it to the signal from the DDC controller. So we're taking that input from the controller, that 2 to 10, 0 to 10, whatever it may be, and we know we have a maximum flow that's allowable through this valve assembly, which is configurable. We set it for an equal percentage flow curve if it's on a heat transfer device, and we continually compare the flow to the signal to make sure we're getting the right GPM through this valve assembly. Nowadays, you can get these in a Dash mod version, which is basically just a RS-485 card that you can configure using the Belimo ZTH-US for either BACnet or Modbus. Don't have to have BACnet or Modbus. It's an option, but the valve works just fine with common, hot, and signal pulled to it. So you can get into the sophisticated side of the controls, or you can just let it wire up and use it like a normal control valve, but it will maintain pressure independence and continually keep that circuit balanced. Again, we use an ultrasonic flow meter. So this is a Bulimo flow meter. We originally purchased mag meters from another vendor, but over time we developed our own ultrasonic flow meter. It's maintenance free. There's no parts to replace or that could get clogged or jammed. And it doesn't really care how clean or dirty the water is. So it's a pretty much a maintenance-free meter. We also offer it standalone. So if you just need a flow meter, we offer it from 1/2 inch to 6 inch by itself. And coming up in a few months, when you see our new catalog, we will be introducing BTU meters as well, or what we call energy meters, using this flow metering technology. Basically, the EPIV, to simplify this, is a VAV box for water. So we have a measuring device, just like a VAV box has. We have a signal, and we have a flow control device, just like a VAV box has. We don't have any reheat coils or anything, but the premise is exactly the same as a VAV box. As the flow in airflow is reduced, but the demand in the space increases, the VAV box is going to open the damper actuator. Same thing with the EPIV. As the flow increases or decreases, we're going to adjust the valve position to make sure we're giving the coil or that circuit the right amount of water flow at any given time. So how that works, we have a flow measurement tolerance, sorry about that, of plus or minus 2% on the flow meter itself. And then we have a flow control tolerance of plus or minus 5% for the valve assembly in its entirety. So a quick example of how that works. If we're out startup, let's say, and we've got 10 volts coming out of our controller, then that 10 volts is measured or equated to 100 gallons per minute. If that measured flow at the flow meter goes up to 105 gallons per minute, the actuator will correct till the measured flow is down to 101 gallons per minute. On the other side, if the flow falls to or below 95 gallons per minute, the actuator will correct till the measured flow is 99 gallons per minute. So we see 2 GPM between 99 and 101. That's where we get our plus or minus accuracy. And then, of course, 105 gallons per minute and 95 gallons per minute, that's our plus or minus 5% in flow tolerance or flow tolerance accuracy. The EPIV, it's available all the way down to a 1/2 inch and all the way up to 6 inches. When we get to the flange sizes, of course, you can get ANSI 125 or ANSI 250 if you've got those bigger high-rise buildings. The valves all have configurable flow ranges. So when we look at these columns on the left, we see, for a very easy example, 30 to 100 GPM. The maximum flow, controllable flow, of this 2-inch valve assembly can be dialed down to 30 gallons per minute. So say you bought a 2-inch EPIV and you thought the coil was 80 gallons per minute, but it's actually 72. You can set it for those 72 gallons per minute or anywhere of a max flow between 30 and 100 GPM. So there is some flexibility with the EPIV. There is generally only one valve assembly for each pipe size, except for 2 inches, where we have a maximum flow of 76.1 on one 2-inch valve, and then a maximum flow of 100 gallons per minute on another 2-inch valve. Initially, we just released the 76.1 max flow, but what we found is there's a lot of 40, 50-ton air handlers out there that need, 80 to 100 gallons per minute to work properly, and jumping up to this next valve size at 2.5 inches, there's a considerable cost no matter what if you're going from a threaded valve to a flange valve. You're just dealing with more heavy metal, a bigger casting. So the valve body itself actually increases in cost. So if you just look at, say, a 2-inch threaded globe valve and compare it to a 2.5-inch flange globe valve, you'll see there's a considerable difference in cost. When it comes to installation, the EPIV and, of course, subsequently the energy valve require 5 times the diameter of straight pipe before the inlet of the valve assembly. So if we got a 2-inch valve, we need 10 inches of straight pipe. On the outlet, we don't care. So, you can install an elbow or something right after the valve's actuator. So one thing to note is that when you're looking at an EPIV installed, the water should go into the flow meter first and then exit through the valve. And that is important because they are unidirectional. The flow meters are unidirectional and they have to be installed the right way. If you reverse the direction and it's installed backwards, it reads 0 flow.
Hey, Steve,
Yeah.
got a question.
On that 3100 range GPM, how adjustable is it? Is it by one GPM increments, or what do you have in between those ranges?
It's by 1 GPM increments, so 30, 31, 32. I've tried to put like a half a gallon per minute in, and it just corrects itself to rounds it up or down.
And on these electronic pressure independent valves, do you offer 3-way options?
Not today. Oh, and you know what? I have to correct myself. On the smaller half and on the smaller flange valves, you can do steps in between full GPM increments. So you can do 1.65, 2.5, things like that on the smaller valves for sure. I think you get 1 decimal place. So
Okay.
I apologize for that. 3-ways, not today. There's a couple ways to go about doing if you have, say, a valve at the end of the loop and you need some form of bypass, there's a couple ways to go about it with combining a pressure independent valve and a regular 3-way valve. Off the record, guys, we do have 3-way energy valves in the European market right now. Will they come to America one day? I hope so. But right now, it's a little bit of a stretch. So we don't have a commercial off-the-shelf 3-way PI valve right now.
Well, verifying flow at the end of my loop is obviously a big concern. So having a control valve that shows me flow rate at the end of my loop would be ideal. But just want to see.
And what we could do there, say we are at the very end of the loop, we're at the last air handler in the piping. We could put a regular 3-way valve in, and then on the leading side, the common port, the AV port, we could attach a PI valve and just set it up to measure, not to control. So we would control with the 3-way, and the PI valve can just measure. Or we could just even simply put a small flow meter on the leading side of that 3-way valve too.
Okay, thanks.
So there's ways. I mean, I've had this question asked a lot of times, and unfortunately, we don't have the all-in-one solution right now, but there's ways to make it happen. Again, as I mentioned with the PIQCV, that smaller valve, it has 2 PT ports in the body. With the EPIV and the energy valve, there are no PT ports, and we really encourage designers to put PT ports, 1 on the entering side of the coil, 1 after the coil and before the valve, and then 1 after the valve. This makes the standard balancing process using a manometer a whole lot easier if you got the PT ports. But one thing I will tell you, because you can use our Belimo ZTH handheld tool or PC tool with the EPIV to actually log in and read active GPMs. At least NEB and the Associated Air Balance Council and TAB to a lesser extent have started to accept our flow meter and the electronic pressure independent valve assembly as a balancing tool. So several years ago, I made it a big point to reach out to all the balancing organizations, volunteer to go speak to them. And for the most part, they are getting on board with using electronic pressure independent valve technology or the Bulimo energy valve as a balancing measurement tool. If MSNS or MSS Solutions offers balancing services, this is a great competitive advantage for your company because we really do simplify the balancing. You don't have to worry about that manometer being calibrated. The flow meter and the energy valve does not require calibration, or the flow meter and the EPIV does not require calibration. So it really gives you an advantage when selling this product after the installation on the more service and maintenance side. So from there, now we've got our little unitary Bulimo PIQCV that's used at the unitary fan coil, reheat coil, VA V-box reheat coil level. We got the EPIV that's for our larger air handler applications, but also goes all the way down to 1.65 gallons per minute. From there, we developed something called the Belimo energy valve. It is built on the chassis of the EPIV. So as you can see, it's got that flow meter. It's got this characterized control valve. It's got some temp sensors. It can be connected to via BACnet, Modbus, or straight up IP, TCP over IP. That is to say, there's a little web server embedded in these actuators, and you can just plug in with an Ethernet cable, bring up a default address, and actually look at what the valve's doing, configure the valve. The way I position the Bulimo energy valve is that it's the easiest valve on the market to work with, because if you can surf the internet, you can view what's going on in the energy valve. Anytime I would go to a job site for tech support purposes, and I would say, is it energy valves or EPIVs? If it was energy valves, my job got considerably easier. You know, with the EPIV, you still have to use either the Bulimo ZTH-US or the Bulimo PC tool. But this, again, you browse into this like you'd be browsing the internet. It's super easy, super intuitive. And because we got all the parts, it works as a BTU meter, and it also can be used to correct low delta T. So if you looked at an ASHRAE journal in the last 20 years, you've seen something called low delta T syndrome. And that's basically when you don't use the chilled or hot water at the point of consumption as efficiently as possible. And if you're not doing that, you're going to flow more water than you need to get the same amount of BTUs. Because when we look at capacity in a space, we look at BTU requirements, and that's simply calculated by the formula 500 times the GPM times the delta T of the coil. So as the delta T goes down, the GPM has to go up to get the same BTUs. And when we look at coil design, this is the formula, again, used to determine capacity of a coil. We look at a submittal, just pulled a random submittal from an air handler, and we see this chilled water coil is designed for 42 degrees in and 56 degrees out at 180 gallons per minute for right around 1.25 million BTUs per hour. If this number goes up above 180 gallons per minute, these numbers are going to start to go down, and we're not going to get any more capacity. You know, their coils are designed based on size, spacing for the fins, tube passes for a capacity. We can't beat the science, if you will. So the Bulimo energy valve has all the components of a BTU meter. We have an actuator, of course, that we can log into that does data logging, and we can view what's going on, and we can set up the control parameters. We have a flow meter with that plus or minus 2% tolerance, a standard off-the-shelf characterized control valve, no different than any other CCV you've seen since 1999 from Bulimo. We have a remote sensor, and we have an onboard or a return sensor. So basically, the BTU meter is comprised of the flow meter and the two sensors. And one thing this valve does is continually run that formula we previously saw of 500 times the GPM times the delta T.
Steve, this is Ryan. One of the ways that we've combated low delta T syndrome, especially in ballroom air handlers and high humidity environments, is by basically changing the control valve strategy to be operated off of discharge air temperature to kind of maintain a set discharge air temperature. And then we've set the fan speed to control off of space temperature. So we're basically turning a giant air handler into a large VAV box, if you will.
Yep.
Does this valve work with that kind of strategy? Can it somehow be a complementary part to that?
Absolutely. So what it's going to do, and first of all, that's a brilliant way to approach that. That's a great control strategy. This will do essentially the fine tuning, if you will. So any little bit amount of slop you might have, it's almost like I guess I could say edge analytics to a degree, but in a mechanical system, right? So we're looking at the water going in, the water going out, and the flow, and we're going to respond to your signal. But as the design parameters get off, we're going to correct just a little bit. So I would say maybe your control system or your sequence of operations get you 75, 80%. We'll pick up the other 20%. Just a little bit of, and thanks for that's a great question, by the way. A little bit of the cost associated with this. If we look at this little graph here and we see we're flowing 55 gallons per minute to get 320 kBTUs per hour at about a 12-degree delta T, and our flow goes up to 65 or by 10 GPM, and we drop our delta down to 10 degrees, and we get about 4% more. No, less, like 2% more BTUs per hour. It costs us another 10 gallons per minute. Doesn't seem like a lot, but when you look at the cost of running the pump, based on the the third law of pump affinity, we can see that the pumping horsepower to get that additional 10 gallons per minute through that coil increases by 65%. So as that happens at multiple locations in the system, it gets to be a lot of increased pumping energy for very little additional yield. And of course, once we start pumping too much water, we compromise the efficiency of the central energy plant. And that's where the savings can be realized. When we calculate GPM requirements, we use the formula tons times 24 divided by the delta T of the distribution loop. So let's say our air handlers are all behaving. We're sending water out at 42 degrees. It's coming back at 54 degrees. We need 1,000 gallons per minute for a 500-ton load. Pretty simple. In this basic example, we got one 500-ton chiller running. If my distribution loop stops behaving, and now I got my delta T down to say like 8 degrees, I need 500 more gallons per minute to achieve that 500-ton load. Therefore, I got to bring on a separate machine, or we have to bring on a separate chiller, the associated pumps, possibly even a tower to maintain the load based on flow requirements, not temperature. So even if you're running a central energy plant optimization scheme, on the evaporator side, we really help fine tune everything at the air handler level or at the edge, as I mentioned a little earlier. Just basic example, if we have a 3,000-ton load and we're pumping 6,000 gallons per minute and we're yielding a 12-degree delta T through the distribution loop, we can run 3 chillers to get our 3,000 tons of cooling. If our delta T drops down to 6%, as we can see, it's linear. We need twice as much GPMs to get the same tonnage at half the delta T. Very basic, I know, but it's a good way to look at optimizing the efficiency of the plant from outside of the plant. Then there's some bells and whistles. So the energy valve, like I mentioned, it has a little web server in the actuator. There's our Ethernet port, and you plug into it and view web pages, and it's very, very intuitive. It also does some data logging. So among other things, it's going to store flow, temperature in and out, energy output, power output, totalized energy, and all elements that we store here in the energy valve in this little actuator can be used to calculate savings. We store 31 days of uncompressed data at about 1 minute or less sampling. And then we store 13 months of compressed data at, I believe it's 2 minutes or more, and depending on the type of data, possibly COV as well.
Hey, Stephen, this is Russell. Do you know, are there any markets that have rebates incentives for these kind of valves?
There are some, Maryland and the DC area definitely have rebates. I'm not 100% up on the programs, but I believe it's called Empower Maryland. And this has been approved for rebates. I believe Con Ed up in New York offers some rebates as well.
What about like California and Hawaii?
I don't know about California and Hawaii. I think that there are some in California. I'd love to fly out to Hawaii and find out for you, but that's not on the list of to-dos. But I can look into that. I have a good friend who manages the West Coast and Hawaii for Belimo, so I can speak with her and find out for sure. I'll make a note of that.
That'd be great. Thank you.
Just write that down. Okay, cool. So communications, like I said earlier, there's an Ethernet port that connects to a little web server in the valve's actuator, so you can plug into it with no special software, no knowledge, no nothing. Type in a default IP address, put in the credentials, and you're in the actuator's web server. You can surf around, you can look at the live data streams, you can make changes, you can do all kinds of stuff. It's BACnet, MSTP, and IP capable, Modbus RTU and TCP capable as well. The important thing to note is all these are optional, that you don't have to use them. Every energy valve comes with all this capability. It's not like it's an a la carte menu where you say, you know what, I want a BACnet energy valve, or I want a Modbus TCP energy valve. All the technology is in the energy valve. There's no licensing. There's no need to use the communications protocol unless you want to. So some of our most successful jobs, we have energy valves hooked up with 3 wires, hot, common, and signal. And the customer is almost unaware of what's going on. And we've been able to go in and help maximize the efficiency based on downloading some data and doing some analysis. So again, it's connectable, but it's not predicated. If you've got a customer with an old, defunct, or barely working DDC system, they have a bad relationship with their DDC provider, this is an excellent way to get into the building. You can do a valve retrofit and actually turn that valve retrofit into an energy savings project. And I'll talk a little bit more about that once we get to our case study. The other thing is we do offer a free cloud service that, as long as the valve is connected, I believe 80% of the time, to the cloud, we extend the warranty of the energy valve from 5 to 7 years.
Steve, did we do that type of valve at the Portland Marriott in the guest rooms, or did we do one that isn't able to be hooked up to that?
Oh, geez, I am not familiar with that project.
Okay.
But we can look into that. If you can give me some details.
No, it's fine. It was Wade's job. I'm not sure if Wade's in the room or not, but we'll find out. That I didn't realize that you had this back end way to actually look at all the valves and basically have a fully functioning control system when it comes to flow, right?
Yes, and again, this is a great, because it's free, and all you need is the Ethernet drops and the ports to get to the cloud. It's a great way to get in as a controls provider, because it's just a valve assembly, and then you leverage the technology and some of the services offered by Bulimo, and you'll find that once you start saving the customer a little bit more money, they're very willing to talk to you about your full control system.
So the valves that were used in Portland were zone tight valves.
Okay.
Pressure independent zone tights.
Little guys.
Your little guys.
Yeah. So that's just an actuator. There's no heavy duty connectivity in the zone tights, but they should be balanced in your system for you.
Yeah, that's why we went with them. I mean, our typical strategy has been not an active valve, but a passive valve, like a Nexus or a Griswold or a Hayes, something that has a maximum GPM flow, but doesn't really do anything for you in terms of turn down, and then just a standard 2-way on-off control valve. So the Portland project was our first sort of what I would call a dynamic control system.
And actually, it's funny you bring that up because we go to market explaining how our PI technology and the energy valve supersedes that concept, because below max flow, we still maintain pressure independence and we continually balance below design flow. So what we're looking at here is this is just one of the pages in the energy valve. So after I've browsed in and I want to set things up or I want to make some changes, you can make changes to the configuration unit. So here you see power is in kBTU and BTU. A lot of times I change that to tonnage because that's more of the language the end users are speaking and the facility managers are speaking. You can set up the control settings, so you can change if you have a bypass application, not a heat transfer application. You can actually make this a equal percentage or a linear flow valve. Here we can see we put the flow maximum flow in. So here it lets you put into up to 3 decimal places. I believe it rounds off at one point in time or another. So yeah, we can dial in a whole lot deeper than I mentioned earlier. This is the Delta T Manager setting where you can enable and disable the Delta T Manager. Now keep in mind, all these things that I'm talking about, these are changes made through the web pages. All these values and all these settings can be adjusted through Modbus registers or BACnet objects as well. So if you're connected BACnet and say you are in a dehumidification strategy and you want full flow through your coil, you might want to disable that Delta T Manager and just go to maximum GPM to dehumidify. You can override from this page, gives you a little bit of information about the valve itself. And then we have our data logging page that I mentioned. Again, the 13 months compressed and 31 days uncompressed data that can be just downloaded in a CSV file form. We also have live data logging, so you can just watch what's going on. You can pick the variables you want to look at. Here, I believe we're looking at the DDC set point, so the 2 to 10 from the controller. We're looking at the actual flow, and we're looking at the projected flow. So if we were not using our Delta T Manager, in this particular scenario, we'd have flowed over 80 gallons per minute where we only needed 40 gallons per minute or so. So that's kind of how this works. And again, it also helps you troubleshoot some other things in the system. You know, it's not a true system diagnostics tool, but if you infer some of the data and you know what's going on in your building, you can use valve position, valve command, flow to determine, you know, if your scheduling's right, if the system's functioning right. There are things, as long as you have a good understanding of controls, you can glean quite a bit from what the energy valve is telling you. We have something called the data analysis tool. So if you pull these data files down, they can be uploaded into our data analysis tool, and we can give you some idea of how the energy valve can help maximize the efficiency of that particular air handler and its coil. We can also do a little bit of a savings estimate. So we can tell you how much water you would have flowed versus how much water you did when the Delta T Manager was actually active and controlling to Delta T. There's also a savings estimator. This is a pretty good little tool. It looks complicated because you need about 15, 16 pieces of information from your end user regarding the size of the system, how many pieces of, how many chillers there are, how often it runs, things like that. But if we get this information that we have a PDF worksheet that you can give to the customer, you can fill out yourself. We can pump that data in. Of course, we need some energy costs and the cost of the project, and actually calculate a simple payback, a return on investment, net present value. It's a fairly sophisticated savings estimator tool. And what we did was Belimo originally developed this in-house. And after a couple of years, we decided that, you know, to really verify it and to really make it a quantifiable tool, we need to bring it to a third party and let them vet it out. So it's been several years ago now. I was in a different position at Bulimo when it was done, but we had a third-party engineering firm vet this, make changes, and now what we're finding is this is a very accurate savings estimator and does help sell some jobs. So quickly, I'll talk about a little case study that happened over in Nashville, Tennessee, where they were buying district chilled water from oh golly, I think it's called N-Wave, possibly. No, can't remember. But they're buying district chilled water. We have multiple district chilled water facilities here in Central Florida, where the customer, instead of putting in chillers, they buy chilled water like a utility. These folks were buying chilled water from their local provider, and they were paying, not only a high tonnage fee, but a penalty for low delta T's. So what we did is we installed a few valves, we calculated some data, and then we made some adjustments. So they did 3 valves as a test, if you will, proof of concept. We took the data, we realized how much we were overflowing and how much we were undershooting the delta T. We adjusted, we maximized the efficiency of those 3 valves. And when we went downstairs, as we were leaving, the building level BTU meter had gone up. The delta T had gone up a little under 2 degrees. Now this is a building with 15 valves, and we did 3. So concept was proved. They installed 11 more valves on the floors and 1 valve on the makeup air unit. Now this was, 6-7 years ago now. The project cost was $53,000 and change. This was a valve replacement. There was not one control technician on this job. They pulled out old globe valves that had hot, basically black, red, and white pulled to them. The only electrical work that was done was unwiring the old globe valves actuator and wiring up those 3 wires to the energy valves actuator. The energy valve did everything else here. One of the big things we noticed was that the minimum and maximum average GPM through this building went down by 200 gallons per minute, to the point where the utility provider was going to send a technician to the building because the flow had dropped so dramatically. Ultimately, on that $54,000 investment, the customer got a simple payback in less than 3 years, 2.4 years. And again, it was a valve replacement that turned out to be an energy savings project.
Steve, we work at the Renaissance. It's on that same loop.
Mm-hmm.
We need to get in front of that hotel with not your whole presentation, but this part of the presentation, and they need to walk down the street and go visit their neighbor that's already done this job. The water that circulates through that chilled water loop is the nastiest stuff. I've been trying to convince them to put in a plate and frame heat exchanger to separate themselves from the terrible water quality that is given to them by the city. It's actually eating their equipment up.
Ooh.
But this, you started your presentation out with, it doesn't really matter how dirty the water is, right? It's not going to mess up our flow meter, that kind of stuff. That's a huge component for that property. So we'll talk later, but I just wanted to interject and let you know that we actually have a building that's on that same loop, and it would that would prove to that customer that something like this is needed.
Great. These are the kind of opportunities that, I salivate over these things because it's very easy. And when you can show them some quantified data and some numbers, it really makes a difference. What we did with that building in Nashville on that loop was they actually provided me 2 years. Yeah, I think it was 2 years of energy bills. And I just crunched the numbers. I kept looking at all the delta T penalties, all the delta T measurements. And then I just did some real basic, multiply, divide, add, subtract calculations. And before that savings estimator existed, gave them a projected, I think my projected savings was 3.1 years, but I kept goosing it up because I was a little nervous about over-promising and under-delivering. But obviously we did the opposite. So installation, again, we have a threaded product and a flange product. What you see here today is our T1, our supply sensor, is in a little T with a well and a temp sensor in it. And then our T2, our return sensor, same thing. It's in a threaded T with a well and a temp sensor. If your system's got wells in it or you don't want to add another fitting, one thing I kind of push back on when we introduce this threaded product with the fittings is we don't want too many fittings in the system, everything causes a little bit of friction loss. So if you have existing wells or you want to just put a hot tap well in, you don't necessarily have to use this T. You can pull the sensor out, put it in a properly sized well with some thermal compound, and it works just fine. In the coming years, in the foreseeable future, this return side temperature sensor on the threaded product will be embedded in the valve's body so that additional fitting and well gets eliminated. Today, with the flange product, the T2 sensor is already installed or embedded in the valve body, so there's no need to worry about that. We provide like a 4-inch well, something like this with the energy valve. But again, you don't have to use this particular well if there's one in the system. Again, as long as it's sized right for the pipe and you use some thermal compound and the sensor stays in there and makes good connection, that'll work fine as well. We do recommend the PT ports for the balancers just in case they want to use their manometer. But again, a lot of the balancing companies or organizations are starting to accept this flow meter technology as a verification of flow on balancing. Same thing with the EPIV as the energy valve, 5 times the diameter of straight pipe. So if you get 2.5 inches, you need 12.5 inches of straight pipe at 2.5 inches in diameter. 2 inches, 10 inches of straight pipe at 2-inch diameter. Really until you get up to 5 and 6 inches, even at 5 inches is just a little bit over 2 foot. 6 inches is 30 inches, so it's about 2.5 foot. At the smaller sizes, the inlet piping is generally not a concern. And the valve can be installed on the supply side. I always recommend any control valve installed on the return side of the coil. But if there's some sort of restriction, something prohibits actually installing it on the return, it can be installed on the supply.
Can you explain why that is? We hear that all the time, but none of us really know why.
Why the valve go on the return side of the coil? Yeah. So one is to keep the coil pressurized, right? We have back pressure on the coil, and that gives you better controllability. So as we start cracking that valve open, we're going to have better controllability, more even heat transfer, and things like that.
Okay.
It's funny. I get that question a lot, and as an organization, we really don't address it in too many of our trainings. So you're not alone in the folks who ask that question, but I wonder if we should maybe be a little more proactive about discussing that. So to summarize, it's actually pretty simple technology, guys. It's a pressure independent valve that has a BTU meter associated with it, basically built into it. It collects data, and with that data, we can maximize the efficiency of an existing piece of equipment or maintain design. So if you're putting new equipment in, we can look at those the submittals. We can look at the coil pages from the air handler submittals and set the energy valves up to make sure the equipment functions per design on the hydronic side. Same thing with the ranges, 1/2 inch to 2-inch threaded, 2 different sizes and maximum flow in the 2-inch valve, 2.5 to 6 flanged up to 713 gallons per minute in ANSI 125 and 250 for your high-rise building. So just quickly, who are we and what have we done? Mr. Anthony Khalil, he is your local Bulimo district sales manager. My name again is Steve Ripka. I've been with Bulimo for about 9 years in a few different capacities. My job today is to help build business through mechanical contractors and their distribution partners. So of course, Brody is part of the picture here. And we've got some jobs that have been installed for many years in the Carolinas. We've got IBM was one of our pilot projects. BMW in Greenville, and I believe Michelin also somewhere in the Greenville area. East Carolina University and Central Piedmont Community College are all fairly substantially sized energy valve installations in your area. So that's it. That is my presentation on the Belimo energy valve. I know there was a lot there, but I would certainly like to open it up to any questions if there are any.
Do you have, so I've seen like I've seen a ton of Bulimo actuators. And I know for outdoor applications, there's like a plastic cover that goes around the actuator. I'm assuming you've got either a 3R rating or some sort of cover for the full assembly if we do have these energy valves?
Yeah, if you've got them outside, we've got weather shields. They're a whole lot more effective and easier if the valve is installed in the horizontal. If it's installed in the vertical, I recommend a little bit of caulk on that leading edge just to make sure we don't get any water in there. In the coming years, one of the big changes we're going to make is that we'll make a full NEMA 4X assembly to where the housing for the flow meters 4X, the housing for the actuator is a separate housing, and it's all NEMA 4X. That's coming. It's not a today thing, but it's on the way. And a good mechanic can make the weather shield work properly. It's it's where the skill of the installer does become a little more important when using our weather shields. Anthony, do you have anything to add or want to contribute?
Steve, I think you did a great job. I think you hit every point. Unless anyone else has any other questions. For me, because I'm replacing Shane Winters, I'm not sure if anyone's worked with him before, but I could send everyone my contact if you want to reach out with any other questions after this.
Yeah, so I missed the first 10 minutes, so you guys probably went over this, but if the team wants to order any of this stuff as part of one of our future projects, who's the contact person for that?
Yep, that's
Gotcha.
correct. Paul is the first line of offense or defense, and then we're here to support Paul. My job is, again, to really build business from mechanicals through distribution. So it's a business development type job, but my background is more technical. I used to have a more technical role at Bulimo, and I got somehow swindled into doing business development. So you got a tech guy doing business development, if you will.
Okay.
Yeah,
Thank
Ryan, I'm in your office right now, and Kevin Riley's my inside guy. He knows these valves pretty well. Either of us.
Great, thank you.
Yeah, I go back to, I've only learned 2 lessons since I've been in sales, which I got out of the field back in 2007. I think I stopped working construction, but all I know is 2 things. Don't piss off your customer and don't sell what you can't support.
Man, we do those every day. Looks like some good sandwiches too. Wes, you want to bring me a sandwich?
Thanks, Steve and Anthony.
Thank you
Yeah.
guys.
Anytime, guys. If y'all need anything, reach out to Paul, reach out to us. We're here to help and, support you any way you need.
Right. Thank you.
All right,
Thank you,
thank y'all.
Thank you.
Steve.